Ladies and gentlemen, good evening and a very warm welcome to our live show from EUMETSAT headquarters here in Darmstadt, Germany. We're just a couple of hours away from the launch of our MTG-S1 satellite. It is set to revolutionize weather forecasting across Europe and way beyond, as you all know. We'll be going live to Cape Canaveral for Liftoff, which will be aboard a SpaceX rocket. I'm Lisa Peterson, I'm a journalist, and I'm delighted to be your host tonight. There are many of us here tonight. You'll see them as you arrived, both here in the council room with us, but also in the main building, but also outside with Jocelyn. He's my co-pilot for the mission tonight, and we are super lucky with the weather. Jocelyn, what's the atmosphere like out there?
Yes, Liz, thank you. Actually, the atmosphere here is fantastic. I'm outside of the headquarters of EUMETSAT, and I have to say, this is fantastic. So many people gathering from all over Europe to witness this historical moment, and I'm actually joining at least one of them. Hello, sir. Could you please tell us your name and where you're from?
Yes, I'm Federico Fierli. I'm Italian, and I work both for EUMETSAT and the European Commission now in Brussels.
Thank you, Federico. And so why is it so important for you to be with us tonight?
Many reasons. Personal, because I'm part of EUMETSAT as well, and I worked on this object for 6 years. And it's really 6 years of work, as many of my colleagues here, that we have put on what is lifting up tonight. And also, in more general way, it's important, because this is knowledge, this is passion of people, this is something that really may change and may improve our capability to take care of the environment. And that's very, very crucial now, especially now.
Well, indeed, and we'll hear later why. Thank you so much, Federico, for your presence tonight. Thank you so much for your support. I am now joining Mark Lantry. Mark, also, you are known as the science guy, right, Mark?
That's me.
Thanks for being with us tonight. You are part of the influencers team who are energizing the MTG-S1 hashtag on social media, right?
Energize is the word. Energize is the word. The buzz is absolutely incredible. So you can probably tell I'm very excited to be here, but also to be able to share this experience with everyone here, people who have been part of the mission, are part of the mission, and the audiences at home as well, to bring them in and make them part of this wonderful event.
So what does it mean for you? What does this moment represent for you deeply?
Well, personally, it's a wonderful moment to be able to share this amazing achievement and revolutionizing and sending this satellite up to give us more information to help us battle against climate change. New information changes the situation. So I've been able to talk with some of the scientists, get information from them, feel the passion about how they've been involved in the project, and the joy that I'm able to come here and enjoy this, but all of us are going to benefit from the data and information from this satellite, and that's the most enjoyable bit.
You say benefit, so why would you say that launching MTG-S1 into space would help everyday people's life? Why?
So that's important, that everyday people are going to get information that directly affects their life as well. Whether it becomes helping with model forecast, better weather prediction, better weather forecast, live storm tracking as well, and monitoring of extreme weather events, which all of us will get impacted on at some point in our lives. And it's important to get real-time information, fast, precise, and accurate, so we can make decisions for ourselves that protect us and protect lives. So that's one of the most amazing things about the satellite, that it will give information that helps save people's lives.
Thank you, Mark. Thank you for being with us tonight. Liz, this is it for now. I will see you soon with more guests. Thank you.
Fantastic. My goodness, what an energy out there. Wonderful. Well, I'll be coming out but later because it's still really, really warm here. So I've got air conditioning. We've all got air conditioning. So we're the lucky ones. To officially kick things off, we have a message from Patrick Schneider. He is the Transport Minister of Germany. And of course, Germany is the host country of EUMETSAT. He couldn't be with us tonight, but he has this message for you.
Director General Evans, distinguished guests, ladies and gentlemen. The French writer Marcel Proust once wrote in his Search for Lost Time, "The only real voyage of discovery consists not in seeking new landscapes, but in having new eyes." In December 2022, with the launch of MTG-I1, the first satellite of the Meteosat Third Generation system, we gained new eyes capable of seeing faster, more clearly, and with greater precision than ever before. Today, we take the next step in that journey. MTG-I1 gave us sharper vision. With MTG-S1, we now gain the ability to listen to the hidden patterns of our atmosphere. We will be able to sense temperature, humidity and gas concentrations in real time with an unprecedented level of accuracy. Combined with the imaging satellite already in orbit, we are at the forefront of technological progress and innovation. Yet the real value of this achievement lies in how it helps us act to save lives, to safeguard infrastructure, and to make informed decisions in the face of climate change and extreme weather. Beyond its technical capabilities, MTG-S1 stands for Europe's enduring commitment to science, cooperation, and excellence. It is a testament to what we can achieve when nations work together, guided by trust, shared purpose, and technical ingenuity. Cross-border scientific collaboration is one of Europe's greatest strengths and one we must preserve. In a world marked by crises and transformation, unity and open exchange are not only vital for science, but for the future of Europe itself. Institutions like EUMETSAT embody this European spirit. That is why Germany has supported EUMETSAT's mission from the very beginning and why it remains a proud and committed host state today. In reaffirming that support today, we are reminded that even in the vastness of space, progress begins with how we look, how we listen, and how we choose to respond to what we learn. In this spirit, all the best for today's launch and for MTG-S1 as it begins its important mission. Go, MTG, go!
And thank you to Herr Schnieder for that message. I am very lucky to be joined here on stage by our very own Phil Evans. We have with us Simonetta Kelly, and we have Elisabeth Hamdusch-Führer, who's with us as well. So let's give them a very warm welcome. Phil, I was commenting on your beautiful shirt. You'll have to have a close look later on during cocktails. As we stand here shortly before this very long-awaited launch, how would you sum up this moment and what it means for Europe? How are you feeling, Phil, today?
Well, thank you. The first thing I'd like to say is, dear colleagues, dear partner, dear friends, it's just fantastic to be able to welcome you here today. In terms of how it feels, I mean, this is a culmination of 20 years effort, and one of the things we'll be doing today is celebrating all the teams in EUMETSAT and ESA and industry who've worked so hard with such dedication to bring an idea, a concept from a piece of paper through to reality. The Meteosat program has been providing imagery and data of the globe for 40 years, 2 generations, that's enabled weather forecasters and others to help protect societies and save lives. And now we're gearing up for the next stage in that with MTG-S1, the first European geostationary sounding satellite that will provide unprecedented data and unprecedented information. That is incredibly important at a time where climate change is increasing the frequency and intensity of severe weather events. And we see far too often the devastating impacts that happen around the world. And of course, the geostationary satellites will help support and provide information to societies in Europe and Africa and other international partners. So EUMETSAT's job is to make sure that the data from these satellites reaches the end users every day, every hour, sometimes every minute to support what they do. And that starts now, or starts in an hour or two, with the launch of this satellite. It's the first stage in that journey. So I'd just like to say welcome to everyone, and thank you very much to everyone.
Thank you, Phil. Simonetta, ESA is celebrating its 50th anniversary, half a century this year. So that's, I know how it feels. So it marks half a century of excellence. It's a reminder, of course, of how important collaborations like this one between ESA, EUMETSAT and many other collaborators have made this kind of mission possible. So what have you to say tonight as we expect this launch?
First of all, welcome to all the guests. Very happy to be here with our two partners at EUMETSAT premises, but with the European Commission. It's 50 years of ESA, but it's also 40 years of collaboration between ESA and EUMETSAT. And this MTG with the sounder on board is the third generation of meteorological missions we are building together. ESA is doing all the procurement, the industrial work, the technical management work, and EUMETSAT providing the requirements and distributing those data sets. It's a very good consolidated collaboration. This new mission is going to improve nowcasting, is going to help to foresee and forecast really extreme weather events, but also it has an instrument on board from Copernicus, very strong collaboration with the Commission. It's a Sentinel-4 instrument. It will help to enhance our information capabilities on atmosphere, on what we know about the atmosphere, all the greenhouse gases, the various elements, and really overall improving all the capabilities that we have collectively in Europe in Earth observation and meteorology. So thank you to everybody. Looking forward to the launch, and go MTG-S, go.
Thank you very much. So, Elisabeth, can you just remind us in a nutshell what the role of the Commission is in this mission?
Yes, so first of all, this is the result of a great partnership. The European Commission is leading on Copernicus, recognized now as the world's most advanced Earth observation system for environmental monitoring, and it's one of the flagships of the European Union's space program. And the European Commission is the program manager for Copernicus and also the owner of the satellites or instruments, as it's the case here with the Sentinel-4 instrument on board of the MTG satellite. And the Sentinel-4 instrument will give important capabilities to Copernicus. And as I said, it's thanks to a strong partnership with EUMETSAT and also with ESA. So thanks a lot for that. And also a strong partnership with the European Centre for Medium Range Weather Forecast for the use of the data later on, and a strong partnership with industry who developed this instrument.
A huge thank you to you, Elisabeth. Let's give Elisabeth a warm welcome, a hand. So, of course, none of this would be happening without one of the other key partners, which is the World Meteorological Organization. Secretary General Celeste Saulo could not be with us this evening, but she has sent us this message.
Dear colleagues and friends, congratulations on yet another milestone. We at the World Meteorological Organization share your excitement and pride. The Meteosat Third Generation satellite system is set to revolutionize weather forecasting. It will enable more precise monitoring of our changing atmosphere, land, and oceans. Every time we check the weather, we rely on something bigger than technology. We rely on international trust, data, and cooperation. Reliable forecasts don't happen by accident. They are made possible by a system of global solidarity. EUMETSAT is a key part of that global solidarity. MTG-S1 will generate a completely new type of data product, especially suited for nowcasting severe weather events. The satellite will change the weather forecast in many ways. MTG-S1 is the first sounding satellite in a geostationary orbit over Europe and Africa. It uses its infrared sounder to capture data on temperature, humidity, and trace gases. Its data is used to generate three-dimensional maps of the atmosphere. MTG-S1 shifts us from flat images to fully three-dimensional views of the atmosphere. This means that forecasters will see exactly what's happening at each altitude. MTG-S1 will be an essential element in support of the implementation of the WMO Integrated Observing System Vision 2040. Further, MTG-S1 will contribute to the UN Secretary-General Early Warning for All initiative. It will strengthen society's resilience to extreme weather and climate impacts. Data will help to detect and predict rapidly evolving and potentially dangerous weather systems. Aviation will be a major beneficiary. The three-dimensional picture of temperature, wind, and humidity will help identify turbulent regions and support smarter and safer flight planning. MTG-S1's infrared sounder can detect greenhouse gases such as carbon monoxide, carbon dioxide, methane, and ozone, thus supporting the long-term records needed to track climate change. WMO looks forward to a successful launch and to the delivery of operational data to the meteorological community. Colleagues, friends, as you may know, WMO this year celebrates 75 years as UN specialized agency. EUMETSAT has just given us a great birthday present. Thank you.
And thank you for that message from the WMO, and I saw you smiling, Simonetta, because, well, they are older than your organization. So thank you very much to our speakers, to the three of you, to our two remote speakers, for setting the stage and reminding us just how important this mission is for Earth observation. Now we're going to go back to the heart of the action with you, Jocelyn, outside. Back to you.
Yes, Liz, thank you very much. I'm here with Sean. Sean, we've heard this is a very innovative satellite, and that will help us to collect a lot of data for the years to come. But could you please tell us, what does it mean for the future generations?
Well, thanks, Jocelyn. I think obviously we're celebrating the launch of a new satellite today. We're also celebrating the launch of a new generation. And as a member of the older generation, I'm still getting real butterflies now, anticipating the launch. I've been here many years and seen many launches, but it's always the same, really fluttering in the tummy. And I think MTG-S1 really represents a major scientific leap. Europe's first operational sounder in geostationary orbits. It will provide meteorologists with the ability to track storms before they strike and actually save lives. So before we, as we look up to the future of weather science, we're also reminded to look ahead to those who will live with the consequences. So with this in mind, the Spirit of the Weather Kids, a global campaign co-led by the WMO and the UNDP, asks a really haunting but very powerful question. What if the weather forecast came from the year 2050, delivered by a child, warning us of what might happen if we don't act today? This campaign went global. It aired in over 80 countries, from localized in more than 40 countries. A child's voice echoed across the airways from France 3 to CNN, from national broadcasts in Africa and Asia to digital billboards in Times Square and video games around the world. So why did this really touch people? This is because while satellites gives us data, as been explained, children give us urgency. The MTG-S1 satellite tells us what is happening, and the Weather Kids remind us why it really matters. So as we launch the MTG-S1 into orbit, this extraordinary tool of science, we're joined today by a very real symbol of that new generation, the other generation, the Weather Kid. So a voice for tomorrow here with us today.
Thank you, Sean. Thank you indeed. This is a beautiful campaign, and actually, fast forward to 2050, Deshna is here with us tonight, and she's about to show us how tomorrow's weather forecast could sound like.
Hi, I'm Deshna with a very special weather report. From up there to down here, everything is crazy. If we don't listen to scientists now, things are going to be even crazier when I grow up. Let's look at the forecast for 2050. Heat waves will affect 94% of children, making playing outside a thing of the past. And severe droughts will wipe out wheat crops, killing the one food my sister eats, bread. And disasters will cost taxpayers almost $6 trillion. My parents hate taxes. Of course, all of this is caused by a blanket of heat-trapping pollution in the atmosphere that we could just, not put up there. But don't worry, there's still a chance of clear skies. Right now, clean energy systems are moving in from the east to the west, creating tons of cool jobs. And solar prices have dropped lower than oil and gas. Going to the satellite, it looks like a high-pressure system of grown-ups could still move in and protect kids from an avalanche of really bad stuff. Some gusty political winds ahead, but they're no match for the power of Hurricane Felicia. That's my mom. We'll keep you posted as we track if adults stop wasting time and solve this totally solvable problem, because it's not just a weather report to us, it's our future.
Deshna, thank you very much and congratulations on your performance. Wow, this is quite touching, to be honest. You already joined us. You're here. Oh my gosh. Okay, you're pretty fast. I'm going to ask a question to Sean first, okay, if you don't mind, Deshna. But congrats to you. So Sean, why does it resonate so deeply, making us feel responsible for taking actions now?
Well, I think all of us have families. Children, I have 3 children, so ensuring our kids are really safe and can have a nice life is the basis of everything we do here in EUMETSAT. We're an operational agency providing data to our member states so they can make informed decisions to manage the planet for the next generation.
Sure, indeed. And you, Deshna, so if you just tonight send a message into space, like this satellite, what would you like the world to hear?
We are running out of time for denial and delay. Climate change is not a distant threat anymore.
It's okay.
Sorry. We are running out of time for denial and delay. Climate change is not a distant threat anymore. It is here and it is affecting every part of life on Earth. We have the technology and tools to fix this. What we lack is the collective will. Every action, whether it's personal, local, national, or global, matters. Every fraction of a degree of warming prevented matters. This is not about what the climate will do to us anymore. It's about what we will do to protect our planet, starting now. Let's act together before it's too late. Thank you.
Thank you very much, Deshna. Thank you so much. I understand your emotion tonight, first of all, to speak in front of the camera, knowing by heart your message. And of course, it's not a light message, it's pretty important. You are the future for all of us. And this is very mandatory and very important. Sean, the last word maybe? You want to share the last word?
I just think it's incredibly touching to hear you speak, and it's said with passion. And I wholeheartedly agree. Thank you very, very much.
Thank you. Thank you both. Thank you very much. Liz, back to you.
Well, thank you so much. And I think here, you should have seen, there were a lot of clapping. Everyone here, Deshna, thought you were amazing. Well done. Well done. Well, I am delighted. As our DG was saying, some 20 years in the making. I mean, this is a massive project. Well, definitely some 15 years in the making. So it's a long journey. And we're going to hear now from you guys, from the teams that have brought this extraordinary satellite to life. I am here with Peter van den Bram-Busse. We have practiced this one. You're from ESA. Rüdiger Schönfeld, that's easy for me, from OHB, and Bertrand Denis from Thales Alenia Space. Gentlemen, a very warm welcome. Let's give them a welcome. Peter, I'd like to start with you. Of course, the agency has been steering this mission alongside EUMETSAT, among others. So what exactly has ESA's role been in developing the satellite and, of course, in the broader MTG program?
We start by defining the system and instrument requirements. And we also define the quality requirements that are applicable to the industrial contracts. For that, as Simonetta said, we start from the user requirements that we receive from EUMETSAT. And then industry, they do the design and the manufacturing of the satellites. And ESA, we place the industrial contracts. We follow up the developments in progress meetings and reviews. And when they define the requirements, it's important we pay attention that we stay on the right side of technical feasibility, but at the same time we try to maximize the return for the users. And sometimes it happens that a certain requirement is not, we discover it's not achievable, and then we sit together with industry and we find a solution together.
So what is it that makes this satellite so very unique?
What's unique about MTG, in the first place, that are the amazing instruments that are on MTG, both I and S. But I'm sure that my MTG and Sentinel-4 colleagues will talk about that later. What's also special about MTG is that it's a geostationary satellite.
Yeah.
Geostationary means it has an orbit such that it makes one rotation of the Earth in one day, so it can follow the Earth when it's on the equator. So it can all the time take the same image on a very regular basis of Europe and Africa, but also it has continuous contact with the ground station and EUMETSAT such that it can transfer the data without almost no delay to the users. It also has a drawback because geostationary is far away. It's 60 times further away than most satellites, so it's important that the instrument zooms a lot, which is an extra challenge for the instrument design to zoom so much, but also for the mechanical design, because if you zoom a lot, it's very important the image is stable. So it's very important that there are no vibrations on the satellite, because the smallest vibration will cause a big displacement on the Earth. So that's a big challenge.
So I think we're going to hear more about these particular challenges from our next speaker. So Rüdiger, thank you very much, Peter, for that. Rüdiger, OHB, of course, has played a major role in developing the satellite. I'd like to know what your teams have been up to. Can you tell us more about that?
Yes.
And if you want to show us close up, your satellite is right here.
Yes, I can show it. but first I would like to thank you for being here and for this important moment in time that we hopefully have a successful launch of the MTG satellite, which is really a big milestone. So what is the role and the responsibility of OHB? So first, let me say, as explained, the MTG is composed basically of 3 missions: the Imager, the Sounder, and the Sentinel-4 mission. And there's one type of satellite which serves for the 2 missions, the Sounder and the Sentinel. This is what we're calling the Sounder satellite. And what we see here on top are the 2 major instruments. It's the IRS, that's a sounding instrument, and the Sentinel-4 for the Copernicus missions. And our responsibility at OHB is, and was, and is still, to build the satellite here with its 2 main instruments. But in addition to this, because with our partner TAS, we were responsible to develop and build a platform, a common platform suitable to serve for the 2 missions, also for the Imager mission, in order to benefit from this commonality. And I can say, within our team with TAS, we achieved a high degree of commonality, and this is also a big achievement. So, and in addition, our responsibility was also to provide the telescopes for the FCI instrument, which is the main instrument of the Imager, working since now, I think, 2 years in orbit and is now in operation.
And how about the further challenges that you encountered, which Peter was mentioning?
Yeah, Peter already described it very well. The main challenge was to transfer this technology to a level that provides the same accuracy, the same type of data as from low LEO orbit, because from these missions we knew the potential of these sounding missions. And the challenge was now to build a completely new instrument capable to provide the high accuracy data also from this geo orbit, which is much far away than the LEO orbit.
Okay. Anything you would like to add before I move on to our friend from TAS?
Yes, first of all, I would also like to thank to TAS for this very good cooperation we had within this 15 years of cooperation. And 15 years is a long time. And if you do not establish such a good cooperation, it's very difficult to be successful. And I think we have shown, TAS has shown with the first mission, we are successful. And we are proud to provide to EUMETSAT and to the weather community this sounding mission. And we hope that this will provide or satisfy all the expectations.
Thank you so
Thanks
much,
a lot.
Rüdiger. Thank you so much for your generous comments on your partners. Thank you. Thank you very much. And
thank you.
And I'll let you regain your spot. So over to you, Bertrand. So your teams at TAS have also, of course, been at the heart of this collaboration. Move forward, gentlemen, so we can actually see you, so the light can really shine into your eyes. Rüdiger as well. So tell us more about your contribution at Thales Alenia Space.
Yeah, we have to come back a bit in the past. We started with we have been, as TAS, the prime contractor for the 3 generations of Meteosat. So we started back in 1977 with the first flight model, and we developed, as such, the 7 model for the first generation, the 4 for the second one, and we are currently leading the development for the 6 of the third generation.
Okay.
So it's
impressive.
Yeah,
absolutely.
And we did it. We have also contribution for the ground segment. So for the first level of data processing and image processing.
And we'll be hearing much more about this later.
Yep, for sure. And we have also with Telespadio the data acquisition plus the command and control of the satellite. So this is a contribution we have. To be more specific about MTG-S, so we made the assembly, test and integration in a facility in Cannes for the main payload, so mentioned by Rüdiger. So there is hopefully a picture just coming.
Yep, coming up.
Yeah, it's coming up. I'm sure it will come. And so we were focusing on our core businesses with the detection plus the optical part. So it was the contribution of my team in TAS.
Yeah, because it's a super complex satellite. This is what Rüdiger and Peter were telling us. So can you perhaps go a little bit further into this complexity?
Yeah, just to remember some element, but you mentioned it. The duration of the development is really amazing. And
my daughter's 15. I know how long that feels.
Well, a bit above the reality, but not that far. So it was long because we had to overcome several challenges, several technical challenges, several industrial challenges. And as mentioned by Rüdiger, I think we did it through a very integrated team with OHB, with a really good work with the agencies, with ESA, with EUMETSAT. And so this is the way we were able to overcome all these challenges.
And it's what we've been hearing since the start of the show. I mean, it's really all about collaboration. That's really the end line. Yeah. And this is what has made it a success so far. So thank you so much, gentlemen. Thank you very much. I think we should give our speakers a big round of applause for diving deeper into the complex technology. Please stay with us. I'm just going to hand over to Jocelyn. So a huge thank you to our speakers. There's much more, of course, as you heard as our speakers were telling us. And for that, I'm going to hand over to Jocelyn because he has at his side a bunch of guests who are going to tell you much more about Sentinel-4. Over to you, Jocelyn.
Exactly, Liz. I'm actually here with 4 guests, and we're about to jump into some stories about Sentinel-4. Lots of fans around you guys. You can see a lot of friends and colleagues taking pictures and photos. Thank you so much. Didier Martien, first question is for you. Could you please explain what it took to develop this mission and give some insight into the Sentinel-4 team?
Well, good evening, Jocelyn, and I'm really excited to be here tonight at EUMETSAT in the final phases of preparation of the launch of MTG-S1, which will be hosting this Sentinel-4 instrument, this fantastic Sentinel-4 instrument, which we will be measuring the composition of the Earth's atmosphere. And the specificity of Sentinel-4 on MTG is that we will be effectively on a geostationary orbit, hovering over the equator. And with our telescope, we'll be looking specifically at Europe, Northern Africa, and with that, we will be focusing actually the measurements of the Earth's atmosphere quality from a constant position. Basically, we'll be looking at trace gases which influence the quality of the Earth's air that we breathe, but also impact climate. You have to know that it's estimated that we have something like about 400,000 premature deaths every year in Europe, directly linked or can be linked to poor air quality, to pollution. And hopefully with this instrument, on the long run, we will be lowering that number considerably. Now, Sentinel-4 is part of the European Commission's Copernicus program. It's yet another mission in this long series of satellites dedicated to Earth observation, where we will be looking, as I said, to the Earth atmosphere and the atmospheric composition specifically. And I must say this has been a tremendous development. The ideas of this instrument started more than 14 years ago when it was finally decided to build such an instrument. It took us still 10 years to design it, to build it, to test it and get it ready for launch today. So it has been a tremendous effort. There are more than 50 companies involved in Europe, with many more supplying companies to those companies. At its peak, about 1,000 highly skilled engineers and scientists who have worked on this mission. So I must say it's a culmination today of this vast effort. And I'm really excited to be seeing this launch today.
Well, thank you very much, Didier. I can feel your excitement, especially after 14 years, like you said. Ben, for you, what makes Sentinel-4 so unique, and why is it so important to make air quality observations, but with a narrowly revisit time?
First of all, I want to thank you for having me here. I'm the Sentinel-4 and Sentinel-5 mission scientist, and I'm super excited after the long time I've been involved in this project to witness now today, and I'm very much hoping to see a successful launch later today. I would like to mention already that in 1 month and a half we will we have another launch planned which brings Sentinel-5 into space. So I'm mission scientist for the two. And I had hoped they would not grow too far apart in time, but now they come almost at the same time, and it's like getting twins. I'm super excited about both, and I'm very much afraid of the blast and wealth of data that will come on my head at the same time. So you were asking what makes Sentinel-4 so unique? It is the first European sensor that is geostationary and that looks at air quality with an hourly revisit time. And this is super important because air quality changes on very fast, very short time scales. The emissions, they change very quickly from the morning rush hour to the afternoon and so forth. There's a long change, and there's also a very strong change in the photochemistry. So all the complicated chemical reactions that happen in the atmosphere, they are very much time dependent and light dependent. So if you look, for example, for the lee of a big city where you think air is bad, and let's go out in the forest, that's where you get the worst ozone values actually. And I think with that it's time to hand over to our scientist.
Thank you, Ben. Thank you very much. Diego, this is your turn now. Could you please describe the contribution of the Scientific Research Institutes on the Sentinel-4 mission?
First of all, thank you very much for giving me the opportunity to be here. For me, it's really a dream come true to be here today. I was very fortunate to start this business in Europe 30 years ago with this kind of instruments. And now today with Sentinel-4, we are giving the next step forward. So back to your questions. The retrieval of information, trace gases from Sentinel-4 is a quite complex task. And we at DLR are leading a team of institutes over Europe doing this. So we are developing the systems for retrieving the trace gases. So that means ozone, nitrogen dioxide, sulfur dioxide, glioxide, formaldehyde, also water vapor, clouds, and aerosol products. And to do this, we have to work together, a big team. We are around 50 scientists in Europe from 11 different institutions, and we developed all these products during the last 10 years. What you see here in the background is an animation of tropomi. That's also an instrument that we are working with. We have ozone and also SO2 from tropomi, but only once per day. With Sentinel-4, we will have this information every hour, and that's really a big step forward for the future. And finally, I would like to thank really all the people that is working with us during all this time, and also the colleagues from ESA and EUMETSAT for the really great collaboration.
So it used to be once a day, now it's 24 times more, right?
Exactly.
Huge improvement.
That's a huge improvement, but it's also a huge challenge to process all this data. We have to develop really a quite complex system. We have a total of 20 software applications. In total, it's more than 1 million lines of code, and also, of course, everything described in documents. And the system is already integrated here in EUMETSAT in the ground segment, and is now actually being tested so that we can really process the data from the beginning, from the mission.
Diego, thank you very much. Last question for Christophe. Christophe, you know. Could you please explain what were the main challenges, the main technical challenges for your team to overcome, please?
Yes. Thank you, first of all, for having me here tonight, and many thanks to EUMETSAT for hosting this beautiful evening here in Darmstadt. I feel incredibly privileged to be here as a representative of Airbus Defence and Space, as a representative also of the Sentinel-4 consortium, and we are all excited about this launch tonight, and we cannot wait to see our instrument deliver data from the geostationary Earth orbit, finally, after so many years of hard work. So about your question, basically this program has never been short of challenges. For us it started well before 2010 already, defining the first concepts, setting up the architecture that would allow for measuring these minute quantities of pollutants in the atmosphere. And it only ended very recently, beginning of the year, basically, when we completed the description of the characteristics of the instrument, which is a key element to the data processing, so that eventually scientists would be able to distinguish the effects in the atmosphere and the contribution that is added by our instrument. So that's very important. But okay, with the 12 years of experience that I have in Sentinel-4, I think without a doubt the most difficult job overall was to build the optical system of this instrument. And the optical system meaning the telescope, the two spectrometers inside, there are two focal plane assemblies inside, and a structure that holds all this in place. So this required really all of our partners to go above and beyond to push technology to the next level. And okay, we have done it successfully.
You've done it successfully, Christophe. I'm sure you did. Congratulations on all your hard work, all of you guys. This is a teamwork. Thank you so much for your time. Thank you for being with us. Liz, we are back to you.
Thank you so much, Jocelyn. You have some fantastic and very enthusiastic speakers, but so do I. I am not jealous because I am here with you, Jochen Grandel and Laurence Roy. Thank you so much for joining us, because now we're going to have a look at what this means for users. We're going to start with you, Jochen. The new infrared sounder is a game changer. We've heard that word quite a few times this evening. So how is it going to help meteorologists detect dangerous storms before they even arrive?
Well, there's this thing called atmospheric instability that we hear a lot mentioned. I mean, it is either in the atmosphere or isn't. That is something that forms, let's say, is there before the clouds form, if we have instability there. So we can't see that with our eyes. And actually, instability means basically lots of humidity or, let's say, thermal gradient in the atmosphere. I mean, this is the kind of technical thing there behind. I mean, that is something that we can observe and actually see that if there is instability, something bad is going to happen in the next few hours. On ground measurements, we can only do, let's say, radiosondes and things like this, which are like very scattered, a few radiosondes here, another one there, every 12 hours or so. That's not very much. And then, I mean, you have also the regional modeling community, which does that quite well, actually. That has really increased in the, let's say, developed in the last, let's say, 10 years or so. I mean, they do a good job. But they are not so good at maybe seeing the kind of a convective initiation point, let's say, spot or point. And they also need the data from us to actually improve that. And that's where the IRS comes into play, because then from that we get the atmospheric profiles of humidity and set temperature and every 30 minutes and everywhere over the full disk.
And that's what creates a shift in early detection.
Exactly. That's what helps us then, because that is before the clouds form.
Okay, super clear. So, of course, as we've said earlier, MTG-S1 is part of a much larger system. So can you give us a full picture and tell us how it works together with the first satellite that we launched a year and a half ago?
Indeed. I mean, MTG-I1, we now call Meteosat 12, was a very good start.
2.5 years ago.
Yeah, that was a very good start. And that provided us with the imager and the lightning imager. And I would say the IRS kind of is the first piece of the puzzle. It goes kind of before that. So with the IRS, as I just explained, it actually sees the situation before the convection starts. So before we have the clouds, when we start actually seeing this kind of mushroom cloud, let's say, forming, that doesn't happen with in this stage yet. Then with the imager, which we had already on the earliest generation, the MTG second generation and so on, or MSG. Meteosat second generation.
We have a lot of time.
Yeah, we have so many Meteosats, you know. Anyway, so the imager can see the clouds and the cloud tops and let's say the cold spots on the cloud tops, which are quite important indeed. They are very important, but there are many of those. So we don't necessarily see or know which is the important ones to concentrate from the forecasting point of view. Where does the forecast actually issue a warning? Is it here or is it there? Is it 50 kilometers north or south? You have many of these these cold cloud tops there. And that's where the lightning imager comes into picture, because it actually shows us where the convective storm is actually most active. And that is the kind of really adding confidence to the forecaster to actually issue the warning in the end, when it's the need for that. So they can ignore the rest of the cold cloud tops they see on the imager and just concentrate on the few which are really dangerous, where the really bad weather comes. Obviously there's bad weather already before, but it's just slightly bad. But the really bad is then where they want to concentrate on.
Okay, and we're actually going to be hearing from these forecasters that you're talking about shortly. They're going to tell us exactly how they're going to be using this new data. Anything you wanted to add, Jochen, or are we ready to move on?
I think
we
move on, yes.
Lars, thank you so much, Jochen, for your very detailed explanations. So from tracking storms to actually tracking something more invisible and, of course, just as critical, and that's air quality. Laurence, having your eyes on quality from space in real time, as we've said tonight, over Europe and Africa, is this going to be a real turning point? So what kind of impact is this going to have, for instance, on public health and climate action, on policy?
Yes, with Sentinel-4, I think that we have reached an unprecedented milestone for the air quality community, in fact. For the first time, high-result, hourly observations of the main pollutants regulated by the EU air quality directives will be available over the whole of Europe. So this is really new. You know that air pollution has harmful effects on human health, on ecosystems. There are also strong linkages between air pollution and climate change. So we need to understand. We need to understand to take actions. And I think that observations are the first step of understanding.
So beyond daily air quality updates, Sentinel-4 is also going to help us understand longer-term trends, inform us on the efficacy of these pollution policies that are put in place, right?
Yes, absolutely. Just to say that Sentinel-4 will be an essential component of the Copernicus Atmosphere Monitoring Service, CAMS landscape, in fact. And CAMS builds upon the combination of Earth observation, in situ observation, and also very sophisticated model to produce forecast, analysis, assessment, trends analysis of atmospheric composition and air quality. And that's very important to, so just you see behind me an example of what we already produce within CAMS. This is really focused on air quality issue. I hope that we will do more thanks to Sentinel-4. So just an illustration of how we monitor and forecast air pollution episodes. On the left side, you see how the Canadian wildfires that happened a couple of weeks ago, combined with desert dust from Sahara to impact Europe, the European domain, and to increase particulate matter concentrations. And you also see a representation on the right side of the ozone episodes that we have experienced in Europe 2 weeks ago. and that starts again today and this week. And this is a kind of thing that we will develop. So this is for the forecasting part that allows to inform the public, to inform the policymakers to take short-term actions. On a longer perspective, with assessment, with trends analysis, we can develop we can assess the efficiency of the mitigation strategies that are decided, that are mostly based on emission reduction strategies. And to conclude, I hope that Sentinel-4 will also feed our developments on the observation-based emission system that we are currently developing to monitor sources and emissions of air pollutants and greenhouse gases everywhere in the world. So today we have some products working on focusing on methane, but I hope that thanks to Sentinel-4 we will be able to expand this service to air pollutants, for instance nitrogen dioxide or ammonia, which are air pollutants as such, but which are also precursors of other pollutants.
Laurence, a huge thank you, and thank you for such a detailed description. It makes us really help us understand how this is going to be used. Talking about which, we're going to go straight back to Jocelyn, because he's outside with some of the experts who are turning this data into real-world impact.
Yes, Liz, indeed. I'm here with Nadia and Mark. Thank you for being with us tonight. We have 8 minutes. We can take our time to just spread your messages. So, Nadia, how will the IRS, the infrared sounder, improve the regional weather forecast compared to the current observation systems that we have now?
Thank you, Jocelyn, for the question. So I'm glad to be here, and I just want to remind you how do we perform a forecast. So we need an atmospheric model which simulates the evolution of the atmosphere. And we need to know the initial state of the atmosphere to run the forecast. And to establish the initial state of this forecast, we need a short-term forecast and observation. And these observations are coming from various sources, such as surface data, radio sounds, aircraft radars, and of course satellite data. And IRS will have, to my opinion, 3 benefits. The first one is that the IRS pixels have a horizontal resolution of about a few kilometers, which corresponds to the model resolution. So it is very well suited for the assimilation. Secondly, we have already said that, but it has a frequency of 30 minutes over Europe, and it will provide very frequent data, more than 24 per day, and it is an advantage compared to the polar orbiting satellites, which overpass the domain of the model only twice a day. And finally, it will bring almost 2,000 pieces of information per pixels, and it is a great improvement compared to the imager. And finally, it covers the whole Earth's disk, and it is very useful for the global numerical weather prediction too.
Thank you, thank you. And you think, could you explain how the IRS will help forecasting extreme weather events, particularly actually over the Mediterranean Sea?
Yeah, convection systems often initiate over oceans, and can lead to heavy precipitation and flash floods over lands later on. And a key element for these systems is the low-level humidity fluxes, which feeds these systems. And IRS has the capability to analyze this humidity at low level, and it will allows us to follow the initial state of this system, and then to provide a good description of the environment of the thunderstorms.
Thank you. I know we'll go deeply into that later with you, Mark. Maybe we have time for one more question. So beyond the traditional weather forecasting, how will IRS contribute to Earth system modeling and understanding long-term processes like the diurnal cycle?
Yes, the IRS spectrum covers a large range of species. So we are able to retrieve some information on temperature and humidity. But this spectrum is also sensitive to ozone, carbon monoxide, and aerosol and desert dust. And we are developing a new Earth system modeling. That means that we are not only taking into account atmosphere, but we are also taking into account surface and atmospheric composition, and IRS has the capability to initiate these models.
Thank you very much, Nadia. Mark, will weather forecaster be using IRS data on daily basis, but directly from
Yes,
work?
they will. So as well as what Nadia has spoken about, which is the incredibly important element of getting the data into the models that forecasters use, alongside that they'll be looking at the data directly. So what they're going to have is in Europe every half an hour, all around that geostationary disk, at least every 6 hours, information about the three-dimensional humidity and temperature structures in the atmosphere. And what they can do with those observations is actually something we're going to have to learn. We've never had such a rich amount of data before. But what we're expecting to happen is, for example, as Jochen was mentioning earlier, the ingredients of those summer convection storms, understanding where is the moisture, where is the humidity, where are the things that are going to enable that air to rise and these summer thunderstorms to start, or processes that actually inhibit that and don't let it get kicked off. Because that can then lead the forecasters to better inform people where exactly are the places of risk in my area of watch. Do I warn people here? This is okay. Maybe later on there's more chance of developing here. So it's an incredibly important set of observations to have.
Yeah, indeed. And like you said, this is very new for Europe, actually. So how are you preparing the weather forecasters to understand and collect those data? I've heard you launch a lot of international workshops.
Yeah, we have, and it's an incredibly fun and rich process. The satellite programs are complicated to do. The observations we have are complex. And there's an incredibly rich amount of learning across the globe. So very recently, for example, we had a workshop with folk from the US, folk from Asia. The Chinese have a satellite that's running at the moment that has a very similar observation. And we're able to learn from them what they've experienced from the colleagues around the world, what they've been able to do with similar data in the past, what kind of weather do we think it's going to be useful for, what exactly are the parameters we have to use, what are the products that we can develop from it. So it's an incredibly rich process, and it's also incredibly good fun to be involved in as well, because you're working with people from different cultures, different research backgrounds, really learning from each other. So it's a beautiful example of knowledge sharing turning into positive action. It's great fun.
I love the stamina. It is great fun, especially to work as a team, globally speaking. And you mentioned, the collaboration or the understanding, outside of Europe. So what about outside of Europe for this satellite,
Yeah, so as Nadia mentioned, the satellite observes the full geostationary disk from what we see. So we're getting observations in Europe every 30 minutes, but we're also getting observations across the whole Atlantic, out towards the Middle East and all of Africa, at least every 6 hours. And that's going to be a journey to explore how are these data going to be used for a similar set of circumstances. So looking at those severe storms or certain other weather events in all of those locations. I'm part of a couple of WhatsApp groups of forecasters in Africa and the Middle East who are all watching this, and there's lots of buzzing going on my phone because they're all really excited to see what can this data do for us. And that's one of the great things about satellite data, because we collect it, we process it, we pass it on, it gets out to the users, and they make it sing. They're the ones who make it become valuable by putting it into operations and turning it into warnings for the public in the future.
Thank you very much, Nadia, Mark. Thank you so much for your time. Liz, I think we are back to you for the last part of the program just before the launch. right?
Yep, absolutely. Thank you so much, Jocelyn. And we are indeed just under an hour before liftoff, and I am again in fantastic company. I am here with Stefan Bozinski, Niobe Peinado Galan, and Dominika Leskov-Żyżewska, and I hope I said that well. And thank you very much for being with us.
Hello.
Let's give them a warm round of applause. We're going to have a look at how the satellite, the data provided by the satellite is going to make, of course, a real difference for users. We've been discussing this for the last few minutes. Stefan, we're going to start. This is a really nice sequence. Are you all ready? This is super nice. Stefan, we're going to take a step back because we've had our nose right up against, oh no, sorry, it's back there, our lovely satellite, which is down there. But sometimes to understand the importance of what we're doing, we need to change perspective. And this is thankfully something Stefan told me about when we were preparing this sequence. So we're going to look at the bigger picture, and you're going to tell us how this mission is going to change the way we actually understand weather on our planet.
Yes, it's a big question. Of course, everyone's excited to see the data one day, and I don't mind launch events, but my personal launch event will be when the data is actually flowing to the users, and I hope we'll be in as big a party as this one when this is happening. But stepping back a little bit, I want to talk about the overview effect.
Who knows what the overview effect is? Sorry for interrupting, Stefan. Hands up. You're going to learn something today.
So it's an effect that astronauts report when they have seen the Earth with the first time with their own eyes. And that goes back to the first astronauts more than 60 years ago. And they undergo a sudden realization, almost a mental transformation, seeing our beautiful planet, how fragile it is and how maybe unique it is out there in space. And the atmosphere is so thin, it's the skin of an apple, proportions maintained. And although we are all professionals and we serve professional users, I don't think we should stop marveling at the Earth and the Earth system. And of course, we cannot all travel to space, although space tourism is fledgling. But our Earth observation satellites have helped us greatly in seeing the Earth and understanding the Earth as a system. And MTG-S, of course, will be a tremendous contribution to that observation to better understand and predict the Earth system.
Yes, so exactly. So this is what you're explaining to us. It's a very humbling reminder. Thank you so much for sharing that. I definitely learned something from you. So we're going to be able to significantly improve the way we read the planet, is what you're saying. Can you explain a little bit more about that? Then let's get back to Earth.
Yes, I mean, we've heard about this from Jochen and other speakers. But putting data into action is EUMETSAT's job, and we will operate the instruments and distribute the data to our users in real time and globally. And for IRS alone, it's 200 gigabytes per day in real time, so that's a lot of data. And they're very excited about it because simulations have shown that this data will have a big impact on the quality of weather forecasting. And the synergy also between infrared sounder and Sentinel-4 will be tremendous. So, that's how we believe the data will make an impact.
Thank you very much. And we've already been over the geostationary satellite side of things, so I'm going to move straight on to you, Niobe. Thank you so much for sharing, Stefan. So we're going to zoom in from that big picture to the very real day-to-day decisions that meteorologists have to make, Niobe. You work at Spain's National Weather Service. You're a key user of the MTG system. So with your user's perspective, how is this new sounder going to improve forecasting, not just in Spain, but also further afield?
Yes, sir. Thank you very much for the introduction. Good evening, everyone. This type of the severe convection can cause adverse effects at surface, so it is very important to monitor and predict with accuracy the severe convection. Currently, the new Meteosat Third Generation Sounder-1 with the flexible combined imager and the lighting imager provide valuable information about convection events and also from other weather structures. but the new MTG sounder with the infrared sounder on board will provide accurate measurements of temperature and humidity profiles, and therefore of instability indices. Here in this image we can see a supercell that occurred in the city of Soria. The photo was taken by José Quirantes, who is a member of the convection group in IMET and a storm chaser. And this type of severe convection, as well as other convection, are very important and can cause these adverse effects at surface. So it is very important to monitor and to predict them accuracy, not just in Spain, throughout Europe. And the new MTG-S, as I was saying, because I have seen the image and I wanted to remember him, the new sounder with the infrared sounder on board will provide accurate measurements of atmospheric and temperature images and humidity profiles with a vertical resolution never seen before on geostationary satellite. And it will allow a decisive improvement in the characterization of the preconvective environment where this phenomena can occur. So we can see an example of temperature and humidity profile derived from polar gases sensor data in the figure on the bottom left. And furthermore, this type of observation also will be assimilated by numerical models, so they will improve the forecast for sure also.
Okay. Thank you very much, super clear, and thank you for the beautiful pictures.
Yeah.
You work on EUMETSAT's nowcasting satellite application facility. It's called SAF. What added value is this new sounder data going to bring to your users,
Yes, I work at nowcasting staff, which is a key element in bringing users closer to satellite data. At nowcasting staff, we are developing several products to be able to use with this new technology. One of these products is the SI, that is the sounder satellite humidity and instability product that would provide temperature and humidity profiles and therefore instability indices to using the infrared sounder data in combination with surface station data. So this new product will allow to characterize and analyze with high accuracy the atmosphere and the severe convection phenomena. Yeah.
Thank you so much, Niobe. It's
Thank
wonderful
you.
to actually hear from the users themselves. It really gives us a super precise, accurate, very concrete idea of what to expect. Over to you, Dominika. So we know the infrared sounder gives us data on humidity and temperature, but it goes much further than that, right?
Yeah, that's very right. It will be able to provide also data on atmospheric composition. So we talked a lot about Sentinel-4, but actually IRS will be able to track some trace gases. So for example, carbon monoxide or sulfur dioxide. And that will be over the entire disk, so it's also very, very relevant for Africa, and over Europe it will be every 30 minutes.
Exactly, and this is what Laurence was telling us about earlier, of course, concerning the Copernicus program. So the other instrument, which is hitching a ride on board the satellite, of course, is Sentinel-4. How is it going to contribute to providing a much better picture of Europe's atmosphere?
So we've heard a lot today already about Sentinel-4, dedicated to air quality over Europe, rush hour, daily cycle. That's the words that are happening all over here today. But actually, some of the pollution you can't track just once a day if you have a measurement, because it can happen that you have a cloud over and you won't see anything. And also with climate change, we've actually, for example, heat waves happening more and more often.
Such as what we're experiencing right now.
Exactly.
Here in Europe.
We can have also tropospheric ozone pollution episodes like we had actually some weeks ago. So that is very, very important to track. Together with Sentinel-4 with IRS, that will be even more amazing, if it can be. Because it will be a synergy which is unprecedented. We have never had sounder infrared and a spectrometer to measure the whole vertical profile in the atmosphere. And finally, what Laurence was mentioning before, for everyday citizens, this data will provide finally information about emissions. So it's quite complicated techniques, and CAMS is helping with that tremendously. But finally, we'll be able to see emissions, and then it's just one step to smart data-informed policies, and we need those policies, as we've heard with the Weather Kit presentation.
Yeah.
For climate change and for our future.
Brilliant presentation that was. And in a nutshell, because we're running out of time, but of course, just to give us an example, these satellites are also going to help us to respond to much more sudden events as well, right?
Exactly. So, for example, dust storms from Sahara, wildfires that are happening all over recently in smoke, and volcanic emission that is crucial also for safety in aviation. So it will be a lot of data. We need, these are very complex missions, so we will need to wait a moment for the data, but actually I am very, very certain it will be worth it.
A huge thank you to the three of you. Stay with me as I announce the break. Let's give them a super warm round of applause. Thank you so much. And a huge thank you to our online audience. I know you're somewhere there between those two very bright lights. Thank you so much for being with us, and thank you for your presence and for your trust. And we are now going to take a short break. We're going to prepare for the next key phase of the evening. That's the launch of our rocket, which is carrying the MTG-S1 satellite. When we come back, we'll bring you a special message from the teams. They are on site at Cape Canaveral, so stay with us. The countdown continues, and see you after the break. Welcome back to those of you following us online. Thank you for being with us, and to all of you here in the council room here at EUMETSAT headquarters in Darmstadt. So before we join SpaceX for the liftoff at 11:04 p.m. CET, here's a quick message from our teams in Cape Canaveral.
Good morning and greetings from Cape Canaveral. And we're here overseeing and managing the operations of the satellite on the day of the launch. Currently, the satellite, MTG-S1, is sat atop a Falcon 9 rocket over there in the background on pad 39A, waiting for the launch later on today. We are now looking forward with great excitement as to what MTG-S1 will bring us, because this will be the demonstration of the excellence, the collaboration and the cooperation that the teams of ESA, OHB, TAS and EUMETSAT can achieve in the future looking forward.
Also a warm welcome from me from Cape Canaveral. It has been a long time. Teams have been working on the Meteosat Third Generation. It's a great deal here. We are waiting for this now all to happen. Thank you to all those teams all over Europe. It was a great cooperation and we are very excited waiting for the launch which happened in a few. Thank you.
Good evening everybody from Cape Canaveral. Just want to take 1 minute of your time. We're now only a few hours away from the launch of Sentinel-4 and MTGS, and all the lights are green. You can imagine the kind of emotions that are going through my head, and I guess through yours. Huge expectation, big excitement, a bit of nervousness, but most of all, what I feel is an enormous sense of gratitude for all the thousands of colleagues who have made Sentinel-4 come true, with their work, their dedication, their passion, their energy. To all of you, I want to say thank you. Thank you very much. Be proud of what you've done. And now, let's cross our finger and go, Sentinel-4, go. Good luck, everybody.
A huge thank you to the teams. I think Giorgio, he really summed it up, a lot of emotion. Thank you, Alexander, James and Giorgio, for your words from Cape Canaveral. And now from EUMETSAT HQ here in Darmstadt, we're going to go over and hand over to our colleagues at SpaceX in Florida for the live countdown and liftoff. Let's go over to Cape Canaveral and to SpaceX.
Meteorological satellites that observe the atmosphere, ocean, and land surfaces 24 hours a day, 365 days a year. MTG-S1 will be Europe's first operational sounding satellite in geostationary orbit.
Now, MTG-S1 is carrying 2 missions this evening, the infrared sounder and the Copernicus Sentinel-4 ultraviolet visible near-infrared light imaging spectrometer. And in combination with Meteosat 12, which is already in orbit, MTG-S1 will enable weather and climate scientists to get a 4D vision of the dynamics and composition of the atmosphere.
At just about T-minus 13 minutes, everything is looking good for an on-time liftoff of 5:04 p.m. Eastern Time, and the range is ready to support. Weather is currently green for launch with no concerns here at the top of the window. If for any reason we are unable to launch today, a backup opportunity is available tomorrow at the same time. That's 5:04 p.m. Eastern Time. And with that, let's take a look to learn a little bit more about the Falcon 9 supporting today's mission.
There you can see Falcon 9 on your screen, a 2-stage rocket that is 229 feet tall and getting ready for liftoff in just over 12 minutes from now. Now at launch, Falcon 9 produces about 1.75 million pounds of thrust. The bottom section is the first stage, or booster, and is powered by 9 Merlin engines. The 9 Merlin M1D engines burn for the first couple of minutes of flight, carrying Falcon 9 through the thickest layers of Earth's atmosphere.
Early in flight, Falcon 9 performs a gravity turn, a smooth pitch maneuver that adds a slight rate to the first stage to start moving it sideways. Getting to orbit is a bit like throwing a ball so fast it never lands. Once the first stage completes its portion of the mission, it shuts down and separates. Falcon 9 sheds the booster to shed mass, enable recovery of the booster. Stage 2 and the payload keep climbing faster and more efficiently without the extra weight, accelerating to around 17,500 miles per hour or 28,000 kilometers per hour.
That's definitely very fast. Now, after stage separation, stage is powered by a single Merlin vacuum engine, also known as the MVAC. And with its extended nozzle and optimized design, the MVAC provides maximum performance in the vacuum of space. And tonight, we'll ignite that engine twice before deploying the MTG-S1 payload into orbit.
Topping off the rocket stack is the Payload fairing, a 17-foot wide carbon composite shell that protects the satellite during the uphill trip through the atmosphere. There's a photo of the payload being encapsulated in the fairing a few days ago. About 3 minutes into flight, both halves of the fairing will separate and parachute back to Earth. Both fairing halves on today's mission are flying for their first time today. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again on future launches.
Now, so much of what makes Falcon 9 remarkable happens in flight. We have stages separating, the first stage landing itself on a drone ship in the middle of the ocean, fairings parachuting back to Earth, all ready for another flight to space. Every part of Falcon 9 is part of a larger design that comes together to do one thing, and that's to escape gravity. And that is the first step in building our multiplanetary future.
And that's a future I'm definitely excited to be a part of. While the countdown continues, here is a video from our customer for today's mission, EUMETSAT.
Day in, day out, we provide our data. It gets used by weather services and it's used to help people stay safe. All the data that goes into the weather forecast models so that they can then project it forward in time. A lot of what we do in supporting weather forecasting supports action. So the value from our data comes when somebody far down the line does something or makes a decision and takes an action.
And today we're launching.
And climate monitoring.
The infrared sounder can identify regions of instability in the atmosphere before clouds have even started to form. This will allow scientists and engineers to derive a four-dimensional picture of water vapor and temperature in the atmosphere.
In combination with data from Meteosat 12, the synergies will bring impactful benefits to users. It will enable weather and climate scientists to get full vision of the dynamics and composition of the atmosphere.
Both these instruments are, frankly, masterpieces of technology, developed in Europe by European industry and European agencies.
What excites us is the new information we will get with this data. It's not only the data itself, but it will provide more information that we have now, and that's really exciting. And we are looking forward to try to use that data in scientific and in an operational context and help the forecasters to use those data and those information to get better forecasts.
MTG is the culmination of more than a decade of partnership. It takes from a project on paper to a spacecraft that will be launched today over a decade and involves thousands of people and consortium of more than 120 companies which are led by OHB.
I would really like to thank all the teams involved in developing this truly outstanding satellite system. We are really looking forward to seeing this system operational in space, and that starts today with the launch.
Right, so as you can all see, there are slight connection issues with the SpaceX live event, but we'll be reconnecting with them very shortly. Stay tight, and we'll be back shortly with SpaceX.
Good call out there for stage 1 RP loading completion. Next up in the countdown, the transporter erector, or TE, will begin to retract away from Falcon 9. That's the large truss structure you see standing next to the rocket. It's hinged at the base and connected to the launch mount beneath the first stage. First, we'll see the clamp arms open around the Falcon 9 second stage. Then the TE will begin to pivot back, slowly swinging away from the vehicle. And it'll reach full recline at about the T-minus 3 minute and 40 second mark.
Still got a little time there. You might also hear that transporter erector, or TE, be called the strong back. It's the same structure, just a different name. The TE rolls Falcon 9 out to the pad, raises it vertical, and stays connected through the final seconds to launch. It provides fuel, power, telemetry, and command connections between ground systems and Falcon 9.
Just about 40 seconds away from starting to see those clamp arms opening around the second stage on our vehicle stack.
Tanks are pressing for Stromberg retract.
And another good call out there.
Those clamps that you see at the top of the TE help stabilize the second stage ahead of launch. As they open,
the retract has started.
There's that call out there. As they open, the rocket is fully free at the top. Now both stages are nearly fully loaded with about 1 million pounds of propellant, which includes RP1, a highly refined kerosene, and liquid oxygen, which we will also refer to as LOX.
And there you can see those clamp arms beginning to open around the second stage there on your screen. Now, propellant is loaded late in the countdown, and that's intentional. Colder propellants are denser, and denser propellants mean more performance out of the same tanks. The colder it is, the more mass that you can move. And before any of that propellant flows, the plumbing and engines get chilled down, and that prevents thermal shock and boil-off when the ultra-cold liquid starts moving. And you may hear that referred to as engine chill.
Loading wraps in 2 steps. The first stage finishes around T-minus 3 minutes, so we still have got around 30 seconds there, and then the second stage will finish about a minute later. You've probably noticed these white clouds venting from the rocket. It's actually condensation. As the liquid oxygen warms slightly inside the tanks, some of it kind of boils off, and then that gas is vented to manage the pressure. When the vented oxygen hits the warm air outside, it instantly condenses into clouds. It's the same principle as your breath on a cold morning, just a much bigger scale.
Load complete.
Good call out there.
Now at the T-minus 60 second mark, Falcon 9 will enter startup, and at that point, the rocket's onboard flight computers will have taken over. And from then on, the countdown will be fully autonomous.
Once we hit inside of T-minus 2 minutes, the 9 Merlin 1D engines will ignite. Once they're at full power, Falcon 9 will lift off of the pad and begin its climb to orbit. As of now, the payload remains healthy. Falcon 9 is tracking no issues. Weather is still green, and the range is ready to support our T0 of 5:04 p.m. Eastern Time. With that, we're proceeding into the last few minutes here of terminal count.
Coming up shortly, we should hear that.
Stage 2 LOX load complete.
And there's that call out for Stage 2 LOX loading completion. Falcon 9 is now fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Now, next major milestone coming up in about 40 seconds from now will be that call out for Falcon 9 being in startup.
Gas launch closeout.
We should be hearing that call out for Falcon 9 startup in just a few moments from now.
Falcon 9 is in startup.
And great call out there. Lastly, we'll hear the final go, no-go from our launch director.
Launch director, go for launch.
And great call out there. LD is go for launch. So let's sit back and watch as Falcon 9 takes our MTG-S1 mission to space.
T-minus 30 seconds. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go MTG-S1. Vehicle is pushing downrange. Heavy motion to cover.
We've just passed 30 seconds and counting. Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center in Florida. In just a few
Falcon
seconds...
9 power and telemetry are nominal.
Amazing call out there. Everything is nominal. Great to hear. In just a few seconds, we'll throttle the engines down.
Falcon 9 is supersonic.
Great call out again. We'll throttle the engines down in preparation for max Q, a period of maximum aerodynamic pressure.
Now we should be hearing that call out for max Q in just a few moments from now.
Max Q.
Amazing. So we just heard that call out for max Q. The rocket has just passed. It'll experience the greatest mechanical stress in flight at that point. The rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. You can keep an eye on the Stage 1 telemetry on the bottom of your screen.
Now we're going to have several...
Back in flight chill.
Good call out there. We're going to have several events coming up in quick succession, and we should hear all of those called out by Mission Control, starting with main engine cutoff, or MECO, then stage separation, SES-1, and lastly, fairing separation. MECO is where we shut down all 9 M1D engines on the first stage. Stage separation is when the first and second stages of Falcon separate from one another.
And second engine start, 1 or SES-1, is when we will light the MVAC engine on the second stage for the first time. Less than a minute later, the fairing will then jettison from the second stage as it's no longer needed to protect the payload once we're in space. So keep an eye out for these events happening back to back. It's all coming up in about 10-15 seconds from now. Just waiting on that. There's that MECO call out they were looking for.
Stage separation confirmed.
MVAC ignition.
And there you heard, maybe even saw those events that happened back to back, which again were MECO, followed by stage separation, and then SES-1. And in just about 20 seconds from now, we'll have fairing separation.
Fairing separation confirmed.
Amazing view there of fairing separation. Now, as we mentioned earlier, we will be attempting to retrieve these fairing halves once they fall back to Earth, and they'll be taken to shore by our ocean recovery vessel, Doug.
We're approaching just about 4 minutes into today's mission. At about T plus 6 minutes, you should see on your screen first stage's entry burn. To start the entry burn, we're going to relight 3 M1D engines, starting with the center engine, known as E9, followed shortly after by E1 and E5, which is similar to pumping the brakes to slow down the vehicle as it passes back into Earth's atmosphere. We need to slow down to reduce re-entry forces, which then helps us recover and reuse the first stage. During that entry burn, Falcon 9 is decelerating by firing its Merlin engines, but we still are moving very fast. This causes the vehicle to fly through Merlin's exhaust gases.
Both vehicles are following a nominal trajectory.
Great call out there, still moving nominal. This causes the vehicle to fly through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle's surface. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, that soot builds up a little more on the outside of the vehicle. Oftentimes, prior to launch, you can see that soot from prior flights on the first stage.
Now, just as a reminder, the second stage of our Falcon rocket is on the right-hand side of your screen, currently taking our payload to orbit, and on the left-hand side of your screen is our Falcon 9 booster, which is going to be making its way back down to Earth. This booster is flying for its 9th time today, having previously supported NASA Crew 9, RRT-1, Firefly Blue Ghost Mission 1, From 2, Sirius XM-10, and 3 Starlink missions. You can keep an eye on the telemetry of both stages at the bottom left-hand corner of your screen for the booster and the right-hand side for the second stage. Coming up in just about 20 seconds from now, we should be hearing the call-out for the entry burn of the Falcon 9 first stage, which, as a reminder, is on the left-hand side of your screen.
Stage 1, entry burn startup.
Stage 1, FTS is saved.
And good call out there for entry burn startup of the Falcon 9 first stage.
Stage 1, entry burn shutdown.
And great call out there for entry burn shutdown of our Falcon 9 first stage.
Great to hear. One of the most iconic things about Falcon 9 is its reusability. It's key to lowering the cost of spaceflight, which enables more investments in critical scientific research. The Falcon 9 first stage that is supporting today's mission is performing this entry burn for the 9th time.
Now, the Merlins on the first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon 9's first stage has thrust greater than 5 747 airplanes at full power. And the MVAC engine on the second stage, which has a much wider nozzle, is optimized to 220,500 pounds of thrust in vacuum.
In a little over 30 seconds, the second stage Merlin vacuum engine will shut down.
Stage 1, entry transonic.
There's that call out there. And after that, we will start our landing burn on the first stage.
Stage 2 is in terminal guidance.
Stage 2, FTS is saved.
Stage 1, landing burn.
And good call out there for the landing burn start on our Falcon 9 first stage.
Nominal orbit insertion. Stage 1, landing leg deploy. Stage 1, landing confirmed.
And there's that call out of landing confirmation for our Falcon 9 first stage. As a reminder, this was the 9th launch and landing for this first stage, which previously launched NASA Crew 9, RRT-1, Firefly, Blue Ghost Mission 1, From 2, Sirius XM-10, and 3 Starlink missions. We also heard a call out for nominal orbital insertion.
And welcome back. And you just missed, I think you can start applauding again because you should see the atmosphere in this room. My goodness. As I was joined on stage by our wonderful next speakers, Gareth, you were just saying, you just never get used to those pictures, right? You were just telling me that. I mean, it makes you feel teary.
It does. This is my 13th launch at EUMETSAT of a satellite, and it's still cool, and it's still.
It is beyond cool.
Yeah.
So anyway, right, back to the show. Okay, so we are let me see, about 10 minutes after liftoff. Everything is running super smoothly. You saw that on the SpaceX program. I'm delighted to be with Gareth, Flavio, and Fausto, and we're going to hear all about the flight dynamics and the LEOP from you. We're going to start with you, Gareth. So, first of all, what happens when the satellite is released by the launcher? This will be happening in about, 30 minutes or so?
Yes, something like that.
Just under 30 minutes.
The satellite is able to detect that it's separated from the launch vehicle. And when that happens, it starts an automatic sequence, which is designed to preserve the satellite, look after it, keep it safe. The first thing it does is it turns on some units, but then it tries to make sure it has electrical power. And that means that it deploys the solar arrays, the big panels that fold out on the sides of the satellite, and it turns the spacecraft to point at the sun. So it maximizes the amount of power it's actually generating at the time. The other thing it does is it starts the setting up of the system to be able to move independently. So far, it's only been able to move because the rocket's been shoving it. Now it needs to prime what's called its unified propulsion system, which allows it to have a big motor, which will eventually be used to change the orbit. Once that's done, then it's a bit more relaxed. The LEOP control center in Ficino then works to communicate with the spacecraft, to have two-way communications, telemetry down to the ground, sending commands up. And it also allows us to then do what's called ranging, which is using the radio signals to figure out where the spacecraft is and what its orbit is.
And there's the screening for debris.
Say again?
The screening for debris?
Yes. The reason why we activate the propulsion system as early as possible is because we need to be able to move out of the way if there's anything that's likely to come close and cause a risk. And we do a screening of that immediately. We know the final orbit to make sure that it's not going to go into the path of anything.
Okay, we don't have that much time, so we're going to run through the next phases as fast as we can. So, how is MTG-S1 being moved into its final orbit? Because it's significantly different to the previous satellite.
It is. There is a slide which will explain a little bit, but we're launching from Florida, which is quite further north compared to Kourou in South America.
Yep.
So we can't launch in the same way. We have to go into a different orbit. Mm-hmm. This orbit is from 250 kilometers above the Earth up to 65,000 kilometers above the Earth. And we do that because by going that high, we can cheat physics and we can change the plane of the orbit much more easily. We're using much less fuel.
Okay, and so the remaining activities that are performed during LEOP, what are those? Take us through those.
Okay. In quick succession, we raise the perigee, we raise the lowest point in the orbit using 3 different burns because we want to make sure that we are as close to our final orbit as possible and to get away from the Van Allen radiation belts, which can damage the spacecraft if we spend too much time in them. We do 3 burns to do that, and we also lower the final orbit from 65,000 down to geostationary altitude as well. And we, as I said, we also turn the plane of the orbit so that it matches the equator. And we end up in an orbit that is basically, I say circular, but it's not quite, such that the spacecraft is then in the geostationary altitude, 35,786 kilometers, and it's drifting round that ring towards the final position, which is at 3.4 degrees west.
Okay, all right, fantastic. And in a nutshell, we have the weather frog. He's here with us.
Yes, Cooper is here. He's been here for the last 25 years.
And he's brought us good luck today. And
we've had good luck so far.
So far.
Fingers crossed, we're not there yet.
Thank you, exactly. Thank you very much, Gareth. So, Flavio, once the LEOP is complete, the next phase, of course, is commissioning the satellite. So you're going to take us through this phase. It's in orbit now. What happens next?
Yes, with the LEOP, the satellite reaches its orbit, and it's a bit like in the famous movie of Stanley Kubrick, it's a new entity delivered in space. At this stage, it cannot do much, but it's our job to transform this fantastic technological machine into a service to the European community, European citizens. For satellite, this is called the system commissioning, which is divided in two phases. One is the satellite in orbit verification, and the other one is a ground data processing test. They are both done with a joint team, an integrated team of EUMETSAT, ESA, and industry experts. And this is what basically allows us to turn this machine into a service for the user. During the commissioning, we have these two phases, which are in the beginning sequential. So first more on the satellite and then on system. But these two parts become more and more interleaved as we approach parts of a real operational scenario, and we basically mimic what service we perform in orbit for the users.
Okay, so can you break down that commissioning phase? What happens and what do your teams have to do?
Yes, I will maybe just go quickly close to the satellite.
Yeah. Sure.
We also have here a mock-up of a satellite. The in-orbit verification is divided in two parts. The one focusing on the platform, which is the bottom part of the satellite. The other one on the payloads. We perform maneuvers. We calibrate actuators and sensors, like the star tracker we see on this side, or the thrusters on the bottom. And we need to establish the optimal configuration for thermal and power, of course. For the payload, first thing we need to do is to unlock the protection device on the IRS, which is meant to protect it from the vibration of the launch we just saw. And then for both instruments, we need to perform the so-called decontamination, which is aimed at removing any sort of impurity that we may have found ground. And then we proceed having say configuration tables and sensor detection setting to optimize the quality of the imaging that we can do.
Okay, so we're going to look a little further ahead. The satellite's fully operational. We're going to imagine that. How long is it going to be before it delivers, well, over how many years will it be delivering services, and what kind of impact can users expect?
So once the commissioning is successful, we relocate it from its test position 3.4 west to 0 degree, which is its operational position. It will be co-located there together with MTG-S1 and with Meteosat 10 at the moment. And from there, we will operate it for the rest of its lifetime, which is planned to be 8.5 years. But in the second generation, we managed to stretch a similar design lifetime for much, much more. So we hope we'll be able to do the same for MTG. This we do normally with what makes the key success of operation, which is flexibility, adaptability, readiness, and reactiveness, and of course, evolution through the time. And this is basically our plan for the future. The MTG-S instruments, together with the MTG-I, will provide a coherent, a unique data set for the atmosphere, and like never was done before. And this will complete the so-called weather cube, which promises to revolution the weather forecast, because it will enable finally the nowcasting and the air quality monitoring.
And we can see the cube on the screen here. We've lost it here, but it's behind, on the screen behind you. So this has been a long personal journey for you as well. I think you have a quick message for the teams involved.
As well, thank you. Yes, it's been actually nearly 20 years I've been, let's say, working and contributing to the development of missions at EUMETSAT. So I am very pleased to see how far EUMETSAT has reached with the cooperation with the ESA and the industry, and which kind of service we can give to our users. And a big, big thank you to the teams of teams which is making this possible.
And a huge thank you to you. Thank you so much. And we're going to, of course, come back to Earth. We've explored what happens in space. So over to you, Flavio. Sorry, Fausto. Sorry.
I knew that.
You knew it was going to happen, didn't you?
We bet.
Did you bet on it? How much did you bet?
Yes.
Oh, no, I had really focused very hard, but there we go. Sorry. Ground segment, of course, crucial part of the mission. Fausto. Can you start, first of all, by reminding us what the ground segment is?
Yes, in simple words, and as the name says, the ground segments are a collection of elements that stays on ground and plays a role in satellite operations and in transforming the instrument data into valuable products for our users. While tonight it's all about sending a satellite into space and starting the LEOP, for us on the ground segment, we're still frantic working to make sure that everything is ready by the time we take over from the LEOP operations. And just like the satellite in space, also the ground segment needs to go through a commissioning phase in which we thoroughly testing all functionalities, and we make sure that the products meet the stringent requirements. In the ground segment, there are two main functions, the monitoring and control, which has already explained, keeps the satellite and the instrument safe and in health. And then the data processing systems, which translates the raw instrument data into usable products and useful products. And this is actually the core of the system, is la raison d'être. So the reason why the MTG system exists is to turn space-based observations into useful, something useful on Earth. Useful for weather forecasting, that, as we've seen before, can save life in the end.
And for your information, we could actually see the slide, which was very clearly identifying what you were telling us. So thank you very much. So can you just go through the main challenges that you encountered in developing the MTG ground segment?
So the monitoring and controlling systems are relatively well established, and we make larger use of existing systems. So personally, I don't consider this particularly difficult or challenging, although it's still complex. And no offense for our satellite operations colleagues. Things get more complicated instead with the data processing system. So the algorithms are really sophisticated, and it takes a long time to get the products to the right level of quality. But above all, most importantly, is that the development of the ground segment has been really a massive team effort. Literally hundreds of people have been working on this project, and it has spanned more over than a decade of time. Personally, I started on MTG in 2011. And I have the impression that it's always been a rush, even if it's a long time.
And I think you have a very personal message as well to pass on.
Yes, exactly. So I would like to express
we need to hear it.
Gratitude to everybody that has been involved. And I would like to conclude saying that this was probably my greatest achievement for my career.
Of your career, wow. So thank you so much. Thank you, Fausto, for sharing that. And thank you, Flavio and Gareth. Stay with me. And we're going to go straight back to Jocelyn, because we're going to meet the dedicated teams from EUMETSAT and ESA who've been working tirelessly behind the scenes to make all of this possible. Over to you, Jocelyn.
Yes, Liz, indeed, thank you very much. This is probably a great achievement for a lot of us tonight. And we are here to take you behind the scenes with a lot of colleagues and collaborators between EUMETSAT and ESA. You are about to share your experience, guys. But before that, let's talk about your feelings right now. I mean, this is clearly a success for tonight. Could you please tell us your emotions right now?
Well, of course, this is a fantastic moment. I've been working in MTG since 2016, and many of my colleagues have been working on it much longer. So this is the, well, not the end of a long journey. It's still going on, but yeah, it's a fantastic point and great success.
Great success. Ilona, you want to share some few words?
Well, I can only add to this. I mean, I have been working on MTG since 17 years, actually, and to see the team, a small team and the small project growing to what it is now and see this launch, it's just amazing. I mean, I cannot say a lot. I mean, I know that the launch we did, and then I still have a bit of fear also, you know, because we're waiting for a signal. So I'm probably too much into it as to be fully joyful already. But yeah, I think it's a great achievement already. So
we'll get the signal.
I'm really still excited. Sure. So let's see.
Daniele?
Yes, so it's a very happy moment. You know, a launch is always a launch. It's full of uncertainty. We are very happy that it went well, and from now on, the journey starts because we are going to have this LEOP period, and then EUMETSAT, we are taking charge of the satellite, and from this moment we start with the long journey of commissioning and entering routine operations. So the fun starts now. So happy to be here.
Thank you. Daniele.
Honestly. A launch is just a step. Okay, it's an exciting step. It's a very public step.
It's not a baby
But for
step.
us, what is critical is when we turn on the instrument, and that would be in September. So that's
Okay, clear enough. Thank you. Tobias, could you please tell us what does each organization bring into this partnership between EUMETSAT and ESA, and what are the specific strengths for each of them?
Yes. So as has probably been explained by many people in the course of this evening, EUMETSAT is the agency that prepares the requirements for the satellite, that is in contact with the scientific users, with the European meteorological agencies and so on. And of course, this is one of their greatest strengths, is that they are in direct contact with the people who actually use the data, so that they know exactly what they need. Also, they also operate these satellites, so they know what is needed for a satellite that is used operationally. Like it's a weather satellite, so it cannot just randomly fail for a few days. Yeah? This is going to be an interruption of service. So these are all very important things that lead to specific technical demands as well.
And for ESA?
And for ESA, it's a mirror image, because we have the direct connection with the European space industry, and we have a lot of experience with implementing requirements into an actual spacecraft, actual instruments. We have the technical expertise to support industry also in developing new technologies, and we've been doing that since the first Meteosat in 1977. So we have a lot of heritage.
Thank you very much, Tobias. Daniele, could you please give us one example of cooperation between ESA and EUMETSAT?
Sure, yeah. I mean, one of the examples I would like to bring here, and it's about a journey that takes ESA and EUMETSAT together here at the start of the commissioning. So we started analyzing, let's say, all the set of requirements we wanted to verify in orbit, and we went through a lot of meetings together, and the ending up of this process was a rehearsal campaign where we were all co-located here in EUMETSAT. We connected the simulator to simulate the behavior of the satellite. And we went through nominal and non-nominal scenarios, and you can really see how groups of people from different organizations start working together as a whole team. And this is what we need to operate the satellite and to be able to cope with the challenges that we will face inevitably with the start of the commissioning. Yeah, that's it.
Thank you very much, Daniele. Ilona, how does it feel for you to be part of such a big team that paved the way for the launch of MTG-S1?
Well, I think sure. I said already, I mean, standing here to watch the launch is really emotionally exciting. I mean, I'm a project controller, so normally I'm working in the back, so to say, behind the scenes, tracking costs and schedules and keeping everything on course, and my colleagues fear me for asking questions like, what about the budget? Whenever they come with new ideas. But in this moment, I really feel like this is very rewarding, because I see how it all contributes to a bigger subject, to a bigger total, so to say. And well, we work together and we get together, and I mean, those get-togethers and keeping the team spirit up, the moral up is also something which I really like. And we saw some photos in the background of the team getting together. Just to mention the MTG Pizzaioli that lately are offering their delicious pizzas to the team, or the LEOP team as a spontaneous get together. You know, before they all went off for the mission, for the launch campaign, for preparing for the launch in Fucino. We had bigger events in Taunus, just an hour from here, basically in the Schloss Friedrichshof, where we were able to go to a library with the full team, you know, an old library, old books, scientific books. And I think we heard some ghosts murmur with excitement about this launch already. So, but last but not least, there's many things like that. But there's also with ESA, we have our bilateral meetings, and we are very happy, you know, to also celebrate there our common activities.
Thank you, Luna. I can feel the happiness behind that. Just to wrap it up, Daniel, how did the project team evolve over its time?
There are many aspects to this question. I selected one, which is the following. Look at the color of my hair. Look how much hair I have left. Look at the wrinkles on my forehead.
You're good,
you know?
better than me.
When I started this project, I was not like this. Okay, this project started in 2010. That's 15 years before we get this wonderful event today. 15 years, when you consider that an engineer has maybe a career of 40 years, that's more than 1/3 of a career. You cannot do many projects like this in your lifetime.
This is a big chunk of your life indeed, Daniel.
Yeah.
And for all of us, thank you so much, guys, for being with us tonight. Congratulations on your success, and I'm sure in September we'll get great signals. Liz, back to you right now.
Thank you, and thank you very much for those testimonies. You got a lot of chuckles in the room here, I think, and a lot of people know how you feel. So now, coming up to separation, we're going to go straight back to SpaceX for the all-important moment.
Welcome back to our continued coverage of the MTG-S1 mission. Now, before the break, the Merlin vacuum engine on the second stage reignited and burned for a little more than a minute before successfully shutting down for the second time.
Now we're a little less than a minute away from expected payload deploy, and we should be able to see that as it happens. A little bit before the break, I was speaking about our customers, so I want to reiterate some of the fantastic things that they're doing here for tonight's mission with EUMETSAT. That is the third Meteosat, the Meteosat Third Generation Sounder, or MTG-S1. It'll be the first European sounding satellite in geostationary orbit. MTG-S1 is the second satellite of the MTG system. The imaging satellite, Meteosat 12, is already in orbit. MTG-S1 carries two missions, the infrared sounder and the Copernicus Sentinel-4 ultraviolet visible near-infrared light imaging spectrometer. In combination with data from Meteosat 12, MTG-S1 will enable weather and climate scientists to get a 4D vision of the dynamics and composition of the atmosphere.
Now, in combination with data from Meteosat 12, MTG-S1 will enable weather and climate scientists to get that 4D vision, and with two different types of satellites, both disseminating data in near real time, MTG is expected to revolutionize numerical weather prediction and nowcasting of high-impact weather in both Europe and Africa. Now we should be hearing that call out for payload deployment in just about 12 seconds from now.
MTG-S1 payload deploy confirmed.
Super exciting call out to hear there. You can see the successful deployment of the MTG-S1 geostationary weather satellite.
And with successful payload deployment, that'll wrap up tonight's live coverage of the MTG-S1 mission. All of us here at SpaceX want to thank our customer, EUMETSAT. We also want to thank the Eastern Range and Federal Aviation Administration for supporting today's mission. Now, if you're interested in more launch coverage, be sure to check spacex.com/launches for the most up-to-date information. And of course, remember to follow @SpaceX on X. Thanks for tuning in, and we'll see you again soon.
Well, two celebrate launch success. Phil was so eager to speak to you that he couldn't wait till the mic was on. So, Phil, over to you.
Thank you. Well, we've just had confirmation of signal from the satellite, which is the key point up until this stage. I mean, what can you say about something like this? It's absolutely astounding. Just step back. Think about what's led to this point. Think about the number of people that have been involved in this. Think about the people in industry, in EUMETSAT, in ESA. Think about the sleepless nights, the hard work, the dedication, the loss of hair, the wrinkled face, to quote someone. Think about all of those things that's led to this point. It's absolutely astounding. And it's all been supported by collaboration and cooperation across industry and public sector agencies, EUMETSAT, ESA. It's a truly astounding thing. But for EUMETSAT, this isn't the end of the story. This is a new chapter. EUMETSAT staff will work overnight and in the coming days to ensure the satellite reaches a safe orbit. And then the next chapter of this satellite will be where it serves society, provides data and information that will genuinely protect lives, protect property, and have a major impact. And for all of the teams that have been involved with this, thank you very much. But take the time to step back and realize what you've achieved and what you've contributed to. Welcome to the fleet, MTG-S1. Thank you very much.
Thank you, Phil. Thank you for your kind words. Phil, over to you, Simonetta.
Thank you. Great moment. We saw how important this mission is, how much dedication, how much work is behind the scenes of this today's symbolic, apical event. I think hundreds of people in industry, lots of people in EUMETSAT, in ESA, a collaboration between free organization, EUMETSAT, the Commission, ESA, many member states supporting it, and the value of this mission, what we will get in terms of nowcasting, in terms of air quality monitoring, is fabulous. So I was at the beginning of the decision of this mission. I must say it's fabulous to be here today also at the moment of the launch, and I would like here to thank all the people involved, everybody who has contributed, all the project teams, of course, on the EUMETSAT side, on ESA side, but particularly also HB teams, Thales teams, everybody who has really supported the development of this project. I'm looking for the next steps.
And a huge thank you for your support. Can I ask you to lend your microphone to our gentleman here, to Abdullah Al-Mandous, you are president of the WMO, and don't fight. There are enough microphones. Over to you.
Well, thank you very much. This is my first.
And please hold the mic up so we want to hear what you're saying.
This is my first time to be
right up against your chin.
Yeah.
Great.
This is my first time to attend the launch of a satellite. It looks like a movie for me, but it is real. This is real. So congratulations for the successful launch of the MTG-S1. I congratulate everybody. I thank everybody, all the team from EUMETSAT, ESA, for their hard work and the dedication of their time on that. I think I'm very excited that the data that we are going to receive, it will be very beneficial for the World Weather Watch and the observation, integrated global observation systems. It will be also helpful, very helpful for early warning for all. Also for the AI and machine learning, will be tremendous in a big data for that. So again, I would like to thank ESA and EUMETSAT for their sustainable support to us and very helpful for our community. Thank you very much. Thank you.
And thank you for being with us. And Owen, over to you.
Thanks very much. And I suppose I represent the EUMETSAT members. So certainly on behalf of EUMETSAT members, I'm privileged to be in a position here to express sincere gratitude to Phil, EUMETSAT, ESA, the European Commission, and all the partners who have brought about this wonderfully successful launch from Cape Canaveral this evening. I think really we've witnessed the birth of a common good. And as has already been said here, this common good will contribute to the protection of life and property and the promotion of societal well-being. And it doesn't just stop there. This mission will contribute to the existing remarkable capability that exists right across this planet to sense the state of the atmosphere and take the pulse of the planet every minute, every hour, every day, every week, right across the planet, driving the remarkable predictive capability that humanity now has. And this will drive the warning systems that the president of the WMO was talking about to protect life and property. And in particular, will contribute not only to European safety, but also the safety of those in least developed countries and small island development countries who need this information and who need effective warning systems now more than ever. And as we face into the future and face the challenges of growing extreme weather and the growth and the intensity of extreme weather, this system will have a massive positive impact on society. Today is a very proud day for science and for society and, as Phil says, for collaboration. Right across Europe, right across the European community, EUMETSAT, EUMETNET, ECMWF, ESA, the European Commission. This type of collaboration is enormous. Our community comes together to acquire scale and to develop the scientific capability and the technical capability to bring about these amazing, strategic, highly significant achievements for society. And as we face the challenges of extreme weather, we all know that the challenges that are facing us all are truly great. But so is the necessity. And I have to say that inspirational achievements like this, I think they serve to give us faith in the future. So for everyone who has contributed to this and to today, thank you and congratulations.
And thank you. And I think I'll just take a few of your words to wrap up. We have witnessed the birth of a common good. I really like the way you described that. Thank you so much, Owen. Thank you to all of you, ladies and gentlemen. And I'm going to let you now celebrate with your teams, because I'm going to go out and join Jocelyn to wrap up. So thank you so much for being with us.
Yes, Liz, you can join me here. I'm starting to feel very comfortable here on the VIP booth outside of the headquarters of EUMETSAT. This is a fantastic and historical moment. We're all happy. Lots of people celebrating, and they have no idea, but I'm coming close to them to talk to them. Hello. How are you? No, don't run away. You're live here. We're on TV. I see you celebrating since the beginning, drinking champagne. How do you feel tonight?
Yes, I feel great, yeah.
I can tell. Who did you come here with? All your friends?
Yes, my colleague, all my colleagues.
All your colleagues, your French colleagues. Are you French too?
Yes.
Don't worry about it. It's okay. We can speak in French, but it's okay. Who speaks better English here? I'm sure you do. Vous êtes Belge, you're Belgium. So you work at EUMETSAT here? You work here?
Yeah, yes, I work here, yeah, yes.
And you work here for how long?
13 years.
13 years. So just after we started on Sentinel-4 and all that. So how does it feel like after 13 years to see the launch and to see the success of it?
I find a great reminder for what you are working for. Yes, I find it beautiful. So it's great. I find, yes, it's the achievement of all the work we have made. So.
Exactly. That's why you deserve champagne now. I'll leave you with that. Thank you very much.
Talking about champagne, have we got it ready?
Oh, she was fast. She heard about the bubbles.
I heard about the bubbles.
Definitely. Thanks for joining me, Liz.
Well, it's been wonderful. It's been wonderful working with you, Jocelyn. It's been especially wonderful working with these teams. You can't see them. The guy opposite me holding the camera, all these guys and all these women behind the scenes, you have no idea. This belongs to you because it wouldn't have been possible without these teams. And so, yeah, thanks to them.
It's always a teamwork.
Absolutely.
Right?
Yeah.
Yes.
So, And thanks to our online audience, to all of these people who've been with us for this event this evening, and to all of you, ladies and gentlemen, who've been with us online. So we look forward to seeing you for further adventures for the MTG journey. See you very soon.
Thank you very much. Bye-bye.
Bye.